I'm Rob Cedar, one of the instructors for the Serious Games and AI course. We've been covering how to use game-like structures for scientific purposes, how to combine those structures with artificial intelligence, and how to build out both of those in working code. The students have been modifying a game about disease propagation and public health, and they've been analyzing it with modern machine learning packages to answer questions about technology and policy. These students have really exceeded our expectations about these advanced topics, and I think you'll be interested to see what they've come up with.
Let's get started. Hello and welcome to Serious Games with AI, part of the MIT Beaver Works Summer Institute 2020 Virtual High School Program. I'm Amna Greaves, and I'm just going to briefly introduce my fellow instructors. Some of them will also introduce themselves. We have Dr. Robert Cedar, we have Joel Korkar, we have Michael Vanderloo, Chris Vanderloo, and Athreya Morali. Together, we have been the team that have been proud and pleased to work with your high school students over the summer and introduce them to Python, to serious games, design of experiments, AI, machine learning, user interface design, the list goes on and on. We've been extremely impressed with how capable these young engineers are, and we are convinced that the future of science and engineering is going to be very strong going forward. So with that, I would like to hand over to Joel Korkar.
Thank you, Amna. My name is Joel Korkar. I'm a staff member at MIT Lincoln Laboratory, teaching the Serious Games and AI course. In this course, the students were charged with modifying and expanding a basic game that we created that investigates different public health mitigations, particularly around disease propagation. It's very relevant in today's climate. We had the students break up into teams, which you will see there are 6 different teams that range from 4 to 6 students per team. Each team was charged with brainstorming and pitching modifications and bringing those to the instructors to making sure that it was the right amount of work for a 4-week program. And then the students were implementing their concepts in the code and putting together the presentation you will see today. Rob will talk next, and he will tell you a little bit about the game itself. Rob?
Hey, I'm Dr. Cedar. I'm tech staff at MIT Lincoln Laboratory. The game we had the students build on top of uses the same kind of disease propagation models that we use in our own research. And it was calibrated to model 2 different threats, a severe strain of flu and a concurrent zombie outbreak. Turns out that these real models are also very good at modeling zombies. And the students modified these in a lot of ways, and it demonstrated a lot of technical skill, both in their programming and their use of machine learning, but it also required a lot of softer skills, working as a team, working remotely, applying best practices in software engineering, and thinking hard about requirements and stakeholders. And we were genuinely impressed by what they accomplished in such a short time.
Thank you, Rob. So what we're going to do is we're going to summarize for you the products of what our class produced. Please roll the video, Joel.
My name is Angela Zhang. I am a rising junior at Newport High School in Washington.
My name is Ray Min. I go to Pineview School for the Gifted in Sarasota, Florida.
My name is Ki Hao. I'm a rising senior at the Bronx High School of Science in New York.
My name is Ji Yoon, and I'm a rising senior at Lexington High School in Massachusetts.
I'm Arif Chaudhary. I'm a rising senior at Stuyvesant High School in New York.
My name is Wanjun Lee, and I am a rising senior at Bergen County Academies in New Jersey.
My name is Amy D'Angelo, and I'm a rising senior at Independence High School in Frisco, Texas.
I'm Megan, and I'm a rising senior at Lexington High School in Massachusetts.
I'm Alex Du, and I'm a rising senior at the Hotchkiss School in Lakeville, Connecticut.
My name is Junho Huang. I'm a rising senior at Limerick High School in San Jose Hill.
My name is Rachel Liu, and I'm a rising senior at the Bronx High School of Science in New York.
My name is Edwin Ng. I am a rising senior at Walter Payne High School in Chicago, Illinois.
Hi, I'm Praneeth Moyala, and I'm a rising senior at Thomas Jefferson High School in Alexandria, Virginia.
I am Annalise Takashigi, and I am a rising senior at the Bronx High School of Science in New York.
My name is Sadiq Sabor. I'm a rising senior at the Bronx High School of Science in New York.
My name is Vivian, and I'm a rising senior at the Noble and Greenough School in Massachusetts.
My name is Connie, and I'm a rising junior at Weston High School of Massachusetts.
My name is Matthew Song. I'm a rising senior at Westford Academy in Westford, Massachusetts.
My name is Ethan Yen. I'm a rising senior at the Bronx High School of Science in New York.
My name is Evan Ackerman, and I go to the Governor School for Science and Math in South Carolina.
I'm Julian Bain. I'm a rising senior. I go to Hellgate High School in Missoula, Montana.
Hi, I'm Henry Gustis, and I'm a rising senior at Niles West High School in Skokie, Illinois.
My name is Jess, and I'm a rising senior at the Pingree School in New Jersey.
I'm Rebecca Ashmore, and I'm a rising senior from Blackstone Valley Tech in Massachusetts.
My name is Isaac Hubbard. I'm a rising senior at Weston High School in Massachusetts.
My name is Alex Malkoff. I'm a rising senior at Needham High School in Needham, Massachusetts.
My name is Lily Weissman, and I'm a rising senior at Stuyvesant High School in New York.
My name is David McElfresh, and I'm a rising senior at Derry Area High School in Derry, Pennsylvania.
My name is Maya Kushemacher, and I'm a rising sophomore at Carroll High School in Southlake, Texas.
My name is Julian Parker Sochori, and I'm a rising senior at Buckingham Brown and Nichols High School in Cambridge, Massachusetts.
Hi, everybody. We are Team Authy1, and I'm Anne. We also have Ray, Connie, Praneeth, and Megan.
So we'll first start with a base game overview of how zombies or flu works. So the idea is there is a city that is divided into 9 areas in a 3x3 grid that represents neighborhoods. And in these neighborhoods, there is a chance for a zombie and a flu virus to occur. The goal of this game is to best control the viruses utilizing the deployments, which can either range from quarantines or to firebombs. Obviously, there's RNG involved in the chances and how quickly the rates spread. And to measure this, there's a score metric which will be used to determine how best controlled the city is going. Additionally, there's a fear metric, which is calculated citywide as the average fear per person. There's also a number of each category, including zombie bitten, dead, ashen, zombie, flu infected, and normal.
Okay, so our first mod is the population individuality mod. And as the name implies, we made different NPCs or people in the game have different personalities. Each personality type makes up a different percent of the total city population, and these personality types range from normal, which is considered least extreme, to Karen, to rebel, each characterized by their own actions and behaviors, but also having their own starting levels of fear, trust, and morale. Those 3 attributes change over time to reflect upon the actions taken by people in the game and by the player. So by implementing these components, we made the game experience become richer and more realistic.
So here is our implementation for the attributes in game. So the way that attributes are affected is that different deployments can increase or decrease attributes from building. And attributes can also passively decrease every turn depending on how many zombies, flu, or dead are in a neighborhood. And the attributes are weighted on a 0 to 100 scale, where 20 is super low, 40 is low, 60 is high, and 80 is super high. So here's our implementation for 2 personalities. And as you can see, the starting attributes are different and the incrementation rates of attributes are also different. So the way that attributes themselves affect the rest of the game, here's an example. High morale can decrease resource costs, while low morale and high fear can increase the cost of resources. So personalities also have special actions. So here's one of them. Karens, rebels, and lunatics are prone to disobeying. And there is also a chance that other NPCs can disobey more or less based on fear or trust levels. So low trust levels or high fear can increase or decrease the chance of disobeying. Here's another special action that can be performed by the rebel. If there is a rebel and there's lower than 20 trusts, other super low trust in a neighborhood, there's a chance that that neighborhood can be locked for a turn. And lastly, the nerd personality can increase or change the chance of a cure vaccine working in the neighborhood.
So our second mod is the disease expansion mod. We made a new feature in our game which simulates the ability for viruses to mutate. So there are chances that either or both the flu and zombie viruses can mutate. So when a mutation occurs, the viruses behave in different ways, such as spreading faster or slower, or making vaccines or cures less effective. And this is similar to how diseases spread and change in real life. We also have a quiet cases feature. Quiet cases only occur a very small percent of the time. They include having no zombies at all, having no flu at all, or having neither zombies nor flu in the game. And this is similar to how outbreaks are not always full-blown in real life.
So here's our implementation for the mutations. There are 7 different types of mutations. The faster or slower mutation will decrease or increase the spread of disease. The lethality up or down mutation can increase or decrease the speed of death once you get the disease. Hinder vaccines or cure mutation will make it less likely for a vaccine or cure to successfully work. And the reverse immunity mutation will make it so that any NPC with a immunity for any reason whatsoever will no longer be immune. Every turn, there's a 10% chance of a mutation happening. And from the 7 mutation pool, each mutation can only happen once. We also implemented quiet cases. At the beginning of every game, there's a probability to not have flu or zombies at all, which is 5% for both, and 0.25% for both together at the same time.
So this is what the UI looked like with the base game. And for a new UI, it looks like this. And what we did is we added indicators for our variables, including fear, trust, and morale. And we added a small description for each personality to give the player a sense of what to expect. Additionally, we added a reset command so that when they finish the game, they can restart. Also, we added an indication as to whether or not the input they entered is a valid action. Also, the game won't break if it's a wrong input, but instead it will ask again. We also added a quality of life improvement in that the location selected will turn red once they're placed to deploy. And finally, we added deployment and location chosen history.
So now we move on to the RL and AI changes that we made. So we basically came up with a new way to calculate score in the game. So we use more specific factors, which makes the way the score is calculated more clear. And they also accurately reflect to what extent we see factors as beneficial or detrimental to the score. In adjusting weights for factors, we made immunity the largest positive factor and zombies the largest negative factor. Additionally, there were some places in the code that we had to change. So we had to expand the state space, which keeps track of the new factors we added. So some deployments cost resources to use. We made that happen. So we track the number of resources used up by the player. And we also track values such as those for the number of healthy or dead people in the game. Finally, we had to expand the observation space too, as expanding the state space directly affects it, and the tracking of new factors there allows for more thorough RL training and more accurate results.
So this is the slide about the data analysis and about the graphs. So basically what we did is that we made a class specifically talking about the human player and the machine player, where the machine player is the AI, and then the human player is just the user. And then we basically had 2 sets of graphs. One graph where it showed the score over time based on the game numbers and the number of times used based on the deployment numbers. And we can compare these 2 sets of graphs to see which one was more effective, the human or the machine. And since we couldn't get real data, we had a few hypotheses on how they should look. And the first one was that the machine player would have a higher overall score than the human with more consistent amounts of increases and fewer downward dips. And the second hypothesis is that the machine player would choose certain deployments more or less often than the human would, which would contribute to their higher score.
And that's the end. Thank you very much for listening to our presentation.
Welcome to Zoff, otherwise known as Zombies or Flu. This game, as previous presentations might have mentioned, puts you in a city of 9 neighborhoods and has you protect innocent civilians from both a zombie outbreak and the flu. You'll have access to various deployments of potential ethical concern and from unknown authorities. But that doesn't matter for now, because what we at Team Authy 2 cared about was more that the base game seemed a little lacking, even impractical. To change that, we decided to get to work. Introducing the GUI mod.
So we've been working extremely hard on a GUI that improves upon the original text-based UI, and we think we have developed a GUI that is markedly better in many aspects. So I'm going to have Sadiq bring it up and show it in action while I walk through all the changes. The first thing we changed is how the user selects their actions. Previously, they had to type out the locations and deployments in the terminal, but now they can do so by clicking the buttons on the screen. Also, when the deployments and locations are selected, they show up in the notification bar above. In our opinion, these changes make the gameplay more seamless and removes the need for a keyboard. We also added events, deployments, and actions to the GUI so the user doesn't have to keep track of it. we finally have the data log. If the user has completed at least one turn, they can access it by clicking the notification bar on top. In short, what a data log is a summary that shows all the changes that occurred after a turn. We added this feature because we thought it would allow the user to analyze the situation more quickly and effectively, and plan accordingly in the next turn. Or they can use it to revisit past turns. The GUI gives them the option to do so. We also made some minor changes, such as to the stats being displayed on the screen, but I'll hand it over to Sadiq to talk a bit more about it.
So we thought that the statistics in the base game were vague, and unreasonably so. They describe things like population size and zombie count in terms such as none or few or many, and we thought this would be a hindrance in planning effective strategies against the flu and the zombie outbreak, and in real life you would have better statistics. So we implemented numerical statistics. Now, just like real life, these aren't 100% accurate, but we thought that as in real life, statistics that aren't 100% accurate are still workable. We made them still workable in our mod. Our next mod is Events and Interactions, which aims to create more realistic NPC interactions. To create conditions for these interactions, we implemented local fear, which is fear inside each neighborhood based on the deployments deployed there rather than across the whole city. And global fear is now based on the local fears of all the neighborhood. Our first event is gatherings, which occur when the population is high and the fear is low. As you'd imagine with a mass gathering, it increases flu transmission and infection amongst the population, and people have a higher chance to stay closer together and within the neighborhood. Our next event are panics, due to high population and also high fear amongst the population. During a panic, people are much more likely to leave the neighborhood, and also it increases the chance for people to fight back against the zombies. Our third event is swarms, which gives more attention to the zombies themselves and occur when there are at least twice as many zombies as there are people. It gives them a chance to actually destroy player deployments, so players should watch out for that. And it also vastly increases the chance for any alive individual to get bitten by a zombie. Now, we did also do some data analysis on agents playing the game, and so I'll hand it off to Arib for that.
I'll be going over the data we've gathered with our RL agents, though to start off with, I'll have to mention that due to a lack of time, we weren't able to fully train our RL agents, so that's probably had an impact on our results. Moving on to our first thing, we have here deployment usages. In the graph below, you can see the difference in usage for each deployment. Let me restart that. Okay, here we can see a graph of the deployment usage by the RL agent after the mod implementation and before it. Comparison between the two over the course of 1,000 games. Our original hypothesis here was that we thought that the RL agent would switch from a more aggressive strategy of firebombing all the zombies and people with flu in order to eliminate them to a more passive strategy of managing fear and removing threats before they appear. We were proven to be correct, as the usage of firebomb barrages had greatly decreased, while the usage of things such as the kiln oversight and the bite center amputate have been increased, with the kiln oversight making sure that dead don't become zombies and the bite center amputate lowering the chance of zombie bitten becoming zombies. Why these results are significant is that it shows how it is why these results are significant is that it shows the necessity to add more realistic aspects to zombies or flu, as the optimal strategy is shifting from the little changes we did. So even more changes are necessary in order to gather practical data that can be applied to a more realistic real life situation. Moving on to our next graph, we have here a local fear versus score, which shows a scatter plot comparing the local fear average of a game compared to the final score of it. Our original hypothesis here was that a local fear average closer to the point where no events occur would result in the highest possible final score, as we thought the events overall would have a negative impact on it. And we were proven to be right, as the place where no events occur was just the local fear of 20 in our implementation. And as you can see here, there is an increasing trend as you look towards 20. Though our entire system for gathering this data was flawed in a way, what we should have done instead was had a wider zone where no events occur towards the median local fear average, and then had the events occur on opposite sides of that zone. That would have allowed us to gather better data in terms of whether or not it's the panics causing the score to lower the gatherings, or if it's the lack of events that do it. We'd also be able to gather data that could be applied to a more realistic situation, as we could see whether or not keeping citizens extremely fearful of what's happening outside, so much so that they panic, keeping them calm enough that they ignore the situation around and start having gatherings even though there's an ongoing flu outbreak, or if there's a very healthy medium between the two, which would result in the most optimal manner for this. That's all we really have for data analysis currently, since we still need to gather more data, so I'll leave the closing statements off to Sadiq.
This has been Team Afi 2. Thanks for watching our presentation, and we hope you all have a good day.
Hi, we're SGAI Team Chris 1, also known as the Best Team Chris. My name is Junha, and we have Maya, Julian, Amy, Wanjun, and Matthew. We made 4 modifications to the game and updated fear, a sanitation value for each neighborhood, an updated deployment mechanism, and a graphical user interface for the game. The main purpose of our mods is to make the game more realistic and more of a model of real life.
The first mod makes fear less impactful in the game. The original Zombies or Flu game was too heavily influenced by fear, so we reduced the value of fear in 2 ways. The first being having a weighted system, and second, changing the points equation. The result of having a reduced fear value is that the player can care more about saving people than reducing fear, as they should in real life. The first thing we did was assign different weights for the amount of fear added when each deployment is deployed. We created these weights in a config file, so if we notice any weights to be inequitable and require changes, we can simply change the value within this file to set the weights to a different number. We also adjusted the score calculations. Good factors, like active NPCs, have a heavier weight, so the score increases by a lot. Bad factors, like zombie NPCs, will have a much smaller relative weight, so the score will go up very little. The score is the sum of these factors multiplied by their respective NPCs in the city. Now look at the picture all the way on the right. Notice how fear holds very little importance in the score calculations. It originally subtracted 1 times its value, and now only subtracts 0.5 its weight. We also figured that there are many factors that would affect the spread of the flu and zombie viruses throughout a neighborhood that weren't addressed in the original game. These factors include income, sanitation, and population density, all of which are important factors when it comes to modeling disease propagation in a city. We added these factors to our game to better model real life, as this is a serious game. To model income, we had each NPC in the game assigned an income to act as their base salary. To model income distribution, we made there be a 50% chance of being poor, a 30% chance of being normal, and a 20% chance of being wealthy. If you are wealthy, you have a 5% lower chance of getting the flu or becoming a zombie, and if you are poor, you have a 5% higher chance. This models real life, as the more money you have, the more money you can spend on sanitation and security measures. To model population density, we just multiplied the number of people alive by 9, then divided the number of people in the neighborhood. Population density does not affect anything directly, but it is a factor in sanitation levels. Now, to model sanitation, we took the average income of a neighborhood and divided by the population density. Then we multiplied that number by a scalar to make the sanitation level more understandable to the user. Sanitation then goes on to affect the fumes, cough, and mutate probabilities. The higher the sanitation level is in a neighborhood, there is a lower probability of the flu spreading in that neighborhood, as a highly sanitized neighborhood in real life would likely spread the flu less.
We also added some functionalities to the deployments in the game. So we added 5 new deployments listed at the bottom of the first picture here. And we thought we would add more deployments so that it would model the real world better, where the decision makers have more deployments to use. We can also add and remove deployments, shown in the second picture. And also with that, we created an input validation sequence so that the user can't remove any invalid deployments or non-existing deployments. So also, deployments are affected by the state of the game. For example, a very high fear would decrease the predictability of that deployment. In other words, when fear is high, it's harder to guess how your actions will impact the city since the people act more irrationally.
These mods to the game mechanics mostly work in the back end to make the model more realistic. To ensure that the user could intuitively play the game, we created a graphical user interface for the user to play the game with. A good UI is crucial for the user to better understand the game and be more likely to play the game.
So this is the graphical UI that we have developed for our game. On the left, I have put the 3x3 tables to show descriptions of each cities and use multiple colors to visualize the data in more appealing ways. We also believe that few non-descriptions was not easy for users to understand, so we have added pie charts to visualize the data. I've also added a graph as the users had difficulty understanding the progress of the game and their past actions. These added features of graphs and charts helped users play the game more quickly and intelligently.
On the right side of the UI, we decided to keep a lot of the information we were presenting in the base game, but make it a little bit easier to understand and more sequential. And so on the right side of the left side, we included the key for the deployments and locations, so the user knows what to type into the input boxes, and then made it easy for the user to select whether they wanted to add or remove deployments. Additionally, we added a quit button to allow the user to exit out of the UI at any time.
To ensure that these mods had a positive effect on gameplay and modeled accurately, we developed a machine learning agent to learn how to play the game. Data visualization is the main feature here, since it helps us gain insight into how the player, whether it be a machine or a human, is interacting with the game.
So we're going to play this video demonstration of a live visual update of the game states while the RL is training. So right now it's only set to train for 1,000 steps. This agent has no prior training. There are two graphs, one for the types of NPCs in the game and one for the score update. The graphs are being updated every game that the agent runs through. So it doesn't look like it's making much progress at all. But let's take a look at the result. So here I'm going to show you the agent that was just trained in the last video actually play the game. Remember, it was only trained for 1,000 steps, which is not a lot. It's not doing too well, which is to be expected. The score has improved a little bit though. Improvements in score are measured by the slope of the score and not the actual value. So a very steep slope is a good thing and a flatter one is a bad thing. Let's take a look at how it performs after 2.5 million iterations. So 2.5 billion steps later, we finally let the machine actually play the game. Then I played the game myself and we compare the performance. The machine's on the left and I am on the right. If you look at the score chart, the machine did very well in the beginning, but I ended up getting a higher score over time. I'd also like to mention that this is just one of the results of the machine's gameplay. We ran it many times with this trained model and we were surprised every time by what we saw. Here we can see which deployments that the agent likes to use. We let it play 35 times and plotted a histogram of its actions. In practicality, this can help us determine which actions are generally helpful and which ones are not. But more interestingly, in the next visualization, we can see exactly when it used a particular development during each step of the games it played. This visualization is very interesting because combined with the previous data, we might be able to see how the machine responded to different situations during gameplay. Of course, this is on a very small scale, only 35 games, but given more time and resources, we could definitely scale this up. We could train our agent for millions more steps and we could have it run for thousands more games. Visualization is a powerful tool. It's a window into what the machine is doing, how it trains, and helps us make better decisions. And in gaining insight into its actions, we might even be able to teach it one day.
So thank you so much for listening. We were Team Chris 1, the best Team Chris, and hope you like our modification of the game.
We are Chris to the Future, the christening. My name is Isaac Hubbard. My team members are Beck Ashmore, Henry Gussis, Jesse Yatvitsky, Kihao Chen, and Vivian Tao. And our mod is the Neighborhood Diversity mod. Picture this. You're the mayor of a city, and a new threat has emerged, the zombie virus. And as well, an old friend comes to battle, the mighty influenza. As the mayor, you'll need to best allocate deployments such as a flu vaccine clinic, a broadcast system, or even a firebomb barrage to save the city from being overrun. However, people are not all the same. People are different. How can you possibly protect the city with different people? Introducing the Neighborhood Diversity mod. By having different traits between neighborhoods, our mod will be more accurate to reality. We built it around our research question. Which neighborhood would require the most government assistance during an outbreak? We anticipated that the wealthiest neighborhood would require the least assistance, while the most impoverished neighborhood would require the most. Additionally, the initial state of each game is also randomized, leading to more complex and varied strategies game to game. This allows for proper analysis of strategies to find the best plan for a real-world crisis. We implemented this by adding individual traits to the neighborhoods and people, which can change the likelihood of zombie and flu transitions and can also influence movement and other characteristics. For example, the wealthy neighborhood is more isolated and is harder to get into or out of. We also added a nicer user interface to increase player engagement and tweak the scoring algorithm to allow for better analysis. The results so far are that the traits themselves don't end up slowing the virus much. However, gameplay strategies can make use of them in other ways. Our AI's best strategy, for instance, is to use specific deployments to bring all the zombies and flu patients into the wealthy neighborhood, since, as I said, it's more difficult to get in or out. It then keeps them there until the end of the game, then firebombs them all at the end. Overall, our mod revamps the game entirely to allow for better and more specific analysis of our research question. With this analysis, we were able to come up with a concrete strategy, and although our AI was unable to save everyone, it had a strategy that could prevent the outbreak from escalating further. And thus, our advice to a mayor in this situation happens to be the same as our team's motto. If it's not up to our standards, we redefine our standards. After all, it is just a game. A serious game. Thank you.
Hello, we are Team Chris 3. I'm Jiyoon and my teammates are Alex, Angela, and Evan. We are implementing a mod that closely represents the fluctuating trust levels of the city people. Here's a quick rundown of how the zombie or flu game works. The user places protective buildings, which shape how the active people, zombies, zombie-bitten, sickly, dead, and dead-ashen act. The user executes various actions to minimize the death or infection of people and maximize the final score. So our trust mod is meant to maximize realism in the modeling of disease propagation. Imagine you're the mayor of the city where new outbreaks of the flu and zombieism arise daily. Of course, citizens will look to you to step up and take authoritative action to ensure their safety. This is precisely the reason why we have added the element of trust between the public and the government. First, we added new buildings that would allow the user more control over the constantly changing trust of the city people. As you can see from this section of our code, each of the 3 new buildings directly affect the trust level of the neighborhood in which they were deployed. The spies are meant to be deployed in neighborhoods that rebel against the mayor when their trust level is dangerously low. When there's a rebellion, the user cannot deploy buildings in that neighborhood unless it is a spy deployment. Now let's look at changes in trust.
The trust for each neighborhood will be an integer between the range of 0 and 100 with 5 different levels. The different trust levels will affect both the NPC's actions and the data displayed to the players. The accuracy of the data is based on their trust. A high level of trust means that the NPCs are more willing to tell the truth. The true data is hidden within a range that is displayed on screen, which widens as trust decreases. If the neighborhood is in rebellion, all data will be displayed as 0 unless a spy is deployed. Higher trust also means that the NPCs will be less hostile, whereas lower trust means that they will be more likely to fight. Now for our randomly generated events. For our randomly generated event scenarios, we have weather, crime, and natural disasters. The types of weathers are sunny, rainy, cloudy, and snowy, which affects the probability of the transitions. For example, in the sunny weather, people are more likely to get bitten because they're outside more. Crime and natural disasters are similar because they are both an unlikely event, and they will significantly lower trust in each neighborhood. Most will also decrease resources to symbolize properties being damaged in real life.
We refer to resources as millions of dollars because it's accurate to the scale of a city. Some buildings produce resources, some cost resources, and others do not affect resources. The passive production of money is dependent on the number of active people in the entire city. The more active people, the higher the net income is. So it's in the user's favor to keep the city people safe and alive so that more money is generated for further deployments.
For the UI, we tried to make the ZOF game feel more immersive so that the player will make more realistic decisions. In the background, we have our city, with 9 clickable neighborhoods in the middle. Pressing the neighborhoods allows the player to see more neighborhood-specific information, such as the amount of zombies and sickly in the neighborhood. Here, a player can place deployments to take their move. At the top, city information is shown, as well as a help button for tutorial purposes and an end turn button to end the current turn and begin the next one.
And here's a short snippet of our game mod in the text-based game.
So a large part of our game modification is our GUI, or graphical user interface. The original game uses a text-based CLI format, which can make it particularly difficult for the user, thereby not really giving us as good of data. Pictured above is a code snippet of our main file for the GUI. This specific piece of code is our central method that listens for user changes, which ends up updating the user interface. We've also implemented a help menu, which is designed for the user to gain vital information concerning the game on screen. And we've also implemented a drop-down menu for the player to choose their deployments.
In this chart, you can see the strategy I've named the police state, which was discovered by our first few fully trained reinforcement learning agents, trained at 1 million steps. Although our ZOF game contains 27 different deployments, the AI consistently used those 2 in this and many other runs. This is most likely because of a weakness in our game where deployment buffs and debuffs remain constant, which makes discovering the best one very easy. Besides this, the scoring function valued trust extremely highly, which is why the police state strategy was born, as don't panic broadcasts and police stations can erase trust in a neighborhood. In this table, we changed how the game scores trust in zombies and trained lots of agents at 1 million steps to determine what are the best deployments depending on what the mayor views as important and unimportant. For example, if the mayor cares more about protecting his people from zombies and flu than his re-election, vaccinations and grouping people together seem to work very well. For the strategy column, I tried to name a real-life equivalent of placing those deployments. As you may notice, the majority of the results rely heavily on the people being forced to obey the mayor. Although you may at first question this finding, many would argue the reason why COVID has been so difficult for America was because of all the freedoms we have.
Thank you.
Hi, I'm Alex, and we're Team A3. My teammates are David, Lily, Julian, and Rachel, and our mod is called Trust Issues. Trust Issues introduces simulations of social behavior not present in the original ZOF. The mod implements a new trust factor, along with changes to deployments, the user interface, and the scoring mechanism. So what exactly is trust? The diagram you see here shows a large part of how trust works in our mod. So the original ZOF includes fear, which measures how much people fear the authorities. Trust will measure how much people actually trust each other. Whereas fear is global, trust is calculated within individual neighborhoods. Fear can also affect trust by setting a cap for it. So as you'll see, trust can range from 0 to 30, and we've set up different bins. So depending on your trust value, you could be in a different bin in each neighborhood. And depending on your global fear, the highest bin you can reach changes, and you can note that on the right with the max bin part. So as an example, if your fear is within 0 to 10, you could have the max amount of trust at 30, but let's say your fear is within 31 to 40, the max amount of trust you could have would be 21. Like the way the fear cap works, trust also influences NPC movement and transition rates based on these different trust bins. So lower trust makes it more likely for an NPC to stay in a neighborhood, whereas higher trust makes it more likely for an NPC to leave a neighborhood. Similarly, depending on each neighborhood's trust bin, the game either increases or decreases the cough, bite, devour, and fight back rates using these different weights that we've labeled here. We included these features for realism's sake. As people lose trust in each other, they become more inclined to stay home and to stay away from other people. In addition to changing in-game mechanics, trust can fluctuate too, based on the numbers of different NPCs in a neighborhood. So if you note the trust in each neighborhood here, if I take a turn of doing nothing, you'll notice that trust has now changed after one turn. So as the number of zombies and sick people increases, trust decreases. And as zombies and sick people become less abundant, trust increases. We included this feature to allow for balancing levels of trust, and to make these fluctuations more realistic, we also allowed trust to change by a small amount in adjacent neighborhoods. Despite this presence of a balancing system, we don't want trust to be fluctuating arbitrarily. We want players to actually have some control over trust levels. So certain deployments can increase or decrease trust, with the most influential one being the new media building that you see here. We'll talk about that in a second. This relationship also works the other way around. Trust can affect certain buildings. So buildings that restrict movement, like the quarantine, become more effective with lower trust levels. And buildings that call for human action, such as the rally point, become less effective with lower trust levels. The last thing we did to even further simulate social behavior was create 2 social groups. At the start of the game, each person is randomly assigned one of these 2 groups, and each neighborhood keeps track of which group holds the majority of people. And so you can see that here where it says majority group. When the game decides movement for each NPC, members of the majority will be more likely to stay, and members of the minority will be more likely to leave a neighborhood. Furthermore, the 2 zombie cure stations and the 2 flu vaccine buildings hold less of an effect on whether that's negative or positive on NPCs of the minority in a neighborhood. We included all these features to simulate different biases that stem from racism, ableism, or xenophobia. We want trust to affect the user's final score, thus the user receives a penalty for decreased amounts of trust and a reward for increased amounts of trust. And this encourages the player to improve trust levels in each neighborhood. As mentioned previously, we want players to have control over trust levels, and so one of our new deployments, the media buildings, satisfy this. The optimistic media building increases trust by 4 every turn, and the pessimistic media building decreases trust by 4 every turn. We also added a new building called the testing facility. These buildings affect the accuracy of reports in each neighborhood, and so you can see that with the few, none. You could also have many. Those are the 3 levels in the original ZOF. With a government-distributed testing facility, your levels can now be very few or some. So all the 5 now could be none, very few, some, or many in that order. The fraudulent testing facility, on the other hand, doesn't actually show these masked reports. However, it shows actual numbers. Yet these numbers have a very high chance of being inaccurate, whether that's by a small or large amount. This makes the building risky to use, but still viable for certain strategies. In addition to these 2 new deployments, we made some slight changes to existing mechanisms. So you can now remove buildings from a neighborhood, and so I can do that here if I remove the fraudulent testing facility I just added. Now it's gone. Deployment, we have a deployment cap of 5 in each neighborhood, so players can't just add tons and tons of buildings to a single neighborhood. And barrage firebombs now destroy all buildings in a neighborhood, so I can show that here. So that's all for buildings and social behavior. Rachel will now talk about UI and score.
We also made changes to the existing UI features and also added our own new features. Neighborhoods now display the deployment in them, as you can see in the display. And this makes the game easier to play because the players are no longer responsible for keeping track of which deployments are in which neighborhood. The deployment table also now shows which deployments affect fear, resources, or trust. If a deployment influences one of those 3 factors, a color-coded arrow either pointing up or pointing for increase or down for decrease is displayed next to the deployment name or an ID, and the keys on the bottom showing what each color means. The mod also introduces a new help command that the player could use when prompted for deployment ID every turn. If the player types in help after building ID when prompted to place a deployment, the game will print out a brief summary of the deployment's effects. We also improved the ending screen of the original game because we wanted to add meaning to the user's final actions. This makes it easier for the user to understand the gravity of their actions, and it also encourages them to search for more effective strategies so they could increase their high score. Finally, the final changes we made in our mod revolve around the scoring system. We changed the scoring algorithm to both encourage the user to further contain the zombie or flu spread and to account for the other features added in our mod. As Alex explained, when discussing social behavior, trust now affects the final score, and resources also now influence the score. To prevent the user from doing nothing the whole game, we made it so that the resources don't provide an extremely high reward, and zombies now result in a higher score penalty. All in all, the user is tasked with maintaining a balance between all the aspects of the serious game to achieve the highest score.
So that's all for our mod trust issues. We hope you enjoyed listening. Thank you.
From serious games with AI, I learned how to train an agent using reinforcement learning and how to implement it into our game.
From serious games with AI, I learned about different commands in command prompt and in Python.
In serious gaming with AI, I learned how to use GitHub and how to utilize my team members' code.
I learned from SGAI how to see through the perspective of a user while developing our game mods.
From serious games with AI, I learned about managing project tasks with Kanban boards.
One thing I learned from SGAI is how to collaborate with other programmers using Git and Kanban board.
One thing I learned with serious games and AI is data visualization with reinforcement learning.
In serious games with AI, I learned the importance of understanding your goals and creating manageable, well-organized tasks for your team and for yourself in order to better achieve your goals.
One thing I learned from SGAI is that communication and collaboration are key for good product development.
In serious games with AI, I learned how to design games with an experimental purpose, as well as how to effectively manage work through Agile.
During my time attending SGAI, I learned about the significance of teamwork and communication for project management and the role of reinforcement learning in serious games.
Through serious games with AI, I've learned more about the collaborative aspect of any software and product development process.
From serious games and AI, I learned how Git works and how it functions with GitHub.
From my experience in serious games with AI, I took away a lot about organizing tasks and time management with the use of Kanban boards.
From SGAI, I learned approaches to software development like Agile.
SGAI, I learned about the importance of daily Scrum and team transparency.
In serious games with AI, I learned the significance of collaborating and communicating with the team in the process of software development through using GitHub and Kanban boards.
In serious games with AI, I learned about collaborative programming using Agile, Kanban boards, and Git.
In SGAI, I learned the importance of good communication habits when using GitHub and Trello. From SGAI, I learned artificial intelligence implementation in Python.
In serious games with AI, I've learned a lot about how to most effectively communicate and work with the team on a coding project.
From SGAI, I learned about how to develop a game's UI, as well as how to use Python.
In SGAI, I learned how to collaborate on code effectively with others using GitHub and Trello.
As part of SGAI, I learned a lot about organization and project management techniques, which I'd not known before.
SGAI, I learned how to write and train machine learning algorithms with Python.
One thing I learned in serious games with AI was how to use advanced Python modules such as NumPy and Matplotlib to analyze data.
SGAI has taught me a lot about the collaborative programming process, including the use of GitHub and Agile practices.
One thing I learned in serious games with AI is how to collaborate with people from all over the country only through a computer.
From SGAI, I've learned how to better manage work and divide it among team members using a Kanban board.
From serious games with AI, I learned how to effectively communicate and work together with a team remotely.
That was awesome. I hope everybody's proud of their products. Let's clap for ourselves, and I'm going to clap for you. Well done. Well done. So what we're going to do now is we're going to hear from each team in turn. So we're going to give each team 5 minutes, and you guys tell us about your experience, what you learned, what you liked, what you didn't like, what you think we could do better. Let's take it away, Team Chris 1.
To start off, the experience working with this team, Team Chris 1, also known as the best Team Chris, was really fun because, well, I personally never worked in a team with for software before, and the experience of coming up with a game modification idea and writing code for it was very, I guess, new to me. And while doing during this course, we learned how to basically model real life accurately of games, and I think that our team did well in figuring out what we could do and what we could not do very early on from the start. So our end product, although we still had some issues maybe here and there, most of it, we felt that it was up to our standards, and it was at the level that we had originally planned it to be at the very start.
Yeah, and there were definitely some difficulties with things like coordinating coding at the same time on the same piece of code, but we figured out how to do it using Git and kind of worked past that. I do think we could have done a little bit of a better job deciding exactly what we wanted to do at the start, but I think overall we did a pretty good job of that and figured it out.
Yeah, these past 4 weeks, I think we've learned a ton. That's just a small description of how much we learned. So we learned things about reinforcement learning, and not only did we learn the concept, we also learned we got to see how it works in actual implementation, and we got to interact with it directly. And there were a lot of obstacles and problems that came up, of course, and those were big challenges to tackle. But it's so rewarding to face up these challenges and successfully overcome them. And the reward isn't only just getting things to work, but the process of actually getting there is what matters the most. And I learned so much from thinking about how to solve problems and exploring different strategies.
Yeah, I agree with Amy. Like, I've learned so much. There's so much I've learned that's not only coding. Like, yeah, I've learned a lot more about Python and Python modules and reinforcement learning, but also just how to communicate with people. I got better at working together in a team, how to coordinate project management, and I've learned so much just that can't be taught much anywhere else.
Yes, like this virtual thing was like very new to me. I've like done some software projects with my classmate and stuff, but working as a team in this like Zoom or Discord was a new experience. And although we were not like face to face, like I think my teammates had like good communication skills, and like we like communicated well to produce this good result.
Yeah, I've never really worked on a team before as well. There's just some solo projects for me, but I really learned like how to formally work in a team in a coding environment, working on a big project with each other. And I think we all did our own thing, and we came together and collaborated, and that worked really well at the end, even though we did have some issues, but I still think we worked out pretty good.
I think you guys did an outstanding job. That was very, very well done. Let's hear from Team A1. Come on, Megan. Let's go.
Okay, so something I would like to start off with something about like SGAI as a course first. So like I really liked how we had most of our lectures before we started working on our project, and that sort of like refreshed all the material we learned before the class started. And it also gave us an overview of everything important we needed to know when working on our project. And that's something I really liked, and like I found that really helpful. And through working on this project, I was able to understand the base code much better, because it seemed like a relatively daunting task at first to like understand so many files of code, each with as many as 1,000 lines. However, as I implemented like more components of our ideas, I began to understand where the code would more logically fit, and how each file was connected to all the other ones, and like how the game functioned as a whole.
Thank you, Megan. Let's talk to... Go ahead.
Oh yeah, SGAI has taught me a lot about working in a professional setting, which I know will translate in the future career. For example, working using GitHub and Agile Manifesto using Kanban boards, something that I know will happen in the future. And I think I gained a lot of valuable experience on how to use Git and how to effectively communicate and manage teamwork strategies to like reach our goals in the end.
Yeah, and another thing something specifically that I learned was about like how UI works in general, and like GUI, like how important it is to make things, to see how, like to focus on how the user would do different actions on a program that you would create. Like thinking about someone who would be relatively new or relatively old to a specific type of program, how they would react to different changes if you would change the background or the implementation. So that's something really important that I learned in general.
I'm glad I got exposed to Kanban boards as part of project management. We used Kanban boards throughout our entire project, which allowed us to divide our project into multiple lists, like one for to-dos, one for progress, one for completed tasks, and this made clear what exactly each person should be working on, and how much we still had left to do. And when each task would do, it made like teamwork and like cooperation and collaboration a lot easier and more efficient.
Adding on to Connie, it wasn't just Kanban boards, but it was also GitHub. So in the beginning, all of us probably had like a really hard time learning it. It was a little difficult, but once we got on the hang of it, it was really easy to see each other's work and work in different branches. So we could merge our code in the end and not end up going to each other's like coding areas and overwriting stuff by accident.
Can I add one more thing?
Absolutely.
So personally, I wish we started coding a bit earlier, because I feel as though we needed some more time to test our code successfully and fix all the errors at the end. But I also feel like although this class was arranged very well for an online course, the communication was definitely less effective for my team than it would have been in person. However, we were able to have meetings every day in Discord to clear up confusion and understand what each person was working on. So Discord, I would say, was very helpful to completing our project.
Cool. We're very happy to hear that. We did our best, given the circumstance, to look for tools and techniques that would help you guys bond and become successful teams. Okay, everybody brace for impact. Here comes Team C2.
So I just want to echo what everyone else said about enjoying collaborative programming and working on GitHub, all of that. But I also like to say I really enjoyed getting to know my team outside of doing work. So yeah, we had a lot of great team meetings and stuff, but we played Pictionary. We had a pretty cool Minecraft session. We had some nice calculus lessons in the Discord. So that would probably be my favorite part, was getting to know everyone on my team and having lots of fun with that. Henry, what do you think?
My favorite part was learning about UI development because I don't really have a lot of experience with code. I learned Python through like the prerequisites for the course. So it was really satisfying to like learn about something like tkinter, the module that I used to help like make the skeleton for the UI. It was really satisfying to like do my research on like how to even make a UI and then find tkinter and then learn how to use it and then just build that and like see it all just kind of stack up and then have everyone help with implementing it and doing all these tweaks. There's a few problems with that though, mainly because like some of us had Mac, some of us had Windows, and the tkinter code would look different depending on which computer you used. So that was probably our biggest problem with regards to the UI, because like I just added random colors when I first started making it. And then I think it was Vivian or Jess pulled it up on their computer and it was like purple and blue and ugly, frankly, just because I was experimenting. But yeah, that was really fun. Another thing that I really liked was that we had a really good communication. As Vivian was saying, we had meetings like every day. We had like a Kanban board, and if you look at that, it looks like the 95 theses, like it's filled. And because of that, none of us, I don't think, were ever really stressed about process, because we all knew what we needed to get done. We started coding like pretty early, so we weren't really rushing at the end. Of course, there was like tons of bugs that we found, but overall, like it was super stress-free. I met some great people, and I'm gonna turn it over to Isaac. What was your favorite part?
Well, my favorite part was actually gaining a lot of sort of practical experience in implementing whatever it is. And I think I'm not the only one in this boat, that before I came into this course, I had a lot of sort of theoretical knowledge about how to write programs and make algorithms and do all whatnot. But I didn't actually have experience developing actual large-scale projects, especially not with a team. And after this 4 weeks, I now have the experience and the capability to actually make something. And I think that's really my favorite part of this. I don't know. I think we should have Jess talk next.
Hi. Okay. So yeah, I agree with Isaac that I definitely learned a lot. Yeah, like I got more experience with Python in general. I got a lot of good experience with like UI and especially like connecting the UI with the backend stuff. That was fun. Yeah, and I also really loved my team. Like everyone was like really nice and always willing to like help each other out and like yeah. And I don't know, like I felt like we had a great group and we had a really fun time. Okay.
Amen to that.
I guess Beck.
Yeah. A lot of my points were things that everyone else said. It was definitely piggybacking off of like Vivian. We were really close as a team. We contacted constantly. We have a lot of memes from it. It's great. And there were like problems initially with trying to figure out how to transfer like skills and teamwork from in person into like on the screen and everything, which was definitely helped a lot with going on to using Kanban boards like Trello and like using Discord to make sure we all like could hear each other with our voices and bounce ideas off of each other. But it was really nice to at least know that like it's not just a bunch of people on a screen trying to figure out things separately. It was very together, like a web, with each of us working on things consecutively and just making sure that we all work together. And it was a really nice experience for being able to like learn so rapidly over those couple of weeks. Yeah.
For me, the most valuable part of the course was to just work on a project of this large, right? Because of that, I found debugging pretty hard. So I had to implement like various ways of debugging. And I also enjoyed my teammates always helping me. Like, for example, Isaac is always helping us with GitHub, and like Vivian is always helping us with organizing a task. And yeah, so like I also enjoy the daily scrums as well.
That was really well done. Let's hear from A2.
All right, I'm going first for A2. And I think I share this experience with like a lot of people, but I generally have not used Git and stuff for like collaborative projects. Mostly I've used it for myself, except for this one time in APCS where I did most of the work anyways. But that's not what this is about. So I did gain a lot of experience in collaborating with other people for them mostly. I mean, the code was one thing. Hands-on experience with Python and stuff, that was one thing. But then also coordinating with your team members and going in voice chats and stuff, and making sure all your branches making sure all your branches are properly set before you merge them into master, and all that to make sure nothing breaks, and log all the bugs in each other's branches and code to go and fix them. I just thought that was really cool, and I hadn't had an experience like that. And it's also good for other people to like look through your code and point out things that you didn't see yourself. And also, so because of that, for example, I went through 3 different implementations of the events mod. So I thought first what I had was a good idea, but then that was wrong. Then I thought what I had second was also a good idea, but that was still wrong. And then third, it worked. I don't know if it's a good idea, but it works well enough.
Yeah, so the course was, in my opinion, was generally pretty good. With the current situation and BWSI obviously becoming virtual, there was a lot of potential for disconnect, and it was harder to communicate. But there was not a point during the course that I felt I was being left out. Collaboration was a big part. Everyone, the TAs and the teachers were really understanding and flexible. I also felt that I was never overwhelmed by the workload, and I often had time to work at my own pace. Overall, it was a good experience. More specifically to our group, at the beginning we had many ideas, but as we progressed, we sort of realized that we weren't able to implement all of the mods. So we sort of had to whittle down to a couple mods, and I wouldn't call it a failure, but it was more of a lesson that simplicity was sometimes good, and that flexibility was something we needed to consider when doing a group project.
Yeah, so I really love this course, and I love what I've gained from it. when I first started this course, I was a little insecure because this is MIT, right? And I figured everyone here was really smart, and I felt a little bit insecure for that. But then everyone here has been very nice. Everyone here has been very helpful. They always explain something to me when I didn't understand it. So by the end of this course, I've become a little bit more confident, and I appreciate that very much. I didn't know a lot about GitHub. I didn't know a lot about Python, but in this entire month, I've learned a lot about it, and I'm pretty okay now, I think. And yeah, working on the GUI has been a big lesson, because I've never worked on anything like that before. Any sort of coding I've done is more casual. I've never worked in a team environment like this. So working with Edwin and Arib and Sadiq has been a very big learning experience.
I have pretty similar things to say. I loved working with all the members of my team, and I loved every part of the course. Though I'd like to mention my favorite part of it, though slightly unrelated to the course, was the mini coding competitions held by the TAs. They gave me a chance to go over all the algorithms I've learned before coming into the course and burn them deeper into my memory to use in the future when I become a software developer or whatever path I take.
Outstanding. Let's hear from C3.
So me personally, I think when I was looking, so my original course was not going virtual, so I had to choose a new one. And then I saw serious gaming with AI, and I was like, what is this? What in the world is this serious gaming? I've never heard of this. And I think the fact that I had no idea what I would expect, that's what drew me to it. So I just wanted to try it out. And I realized that I just learned so much from it. Like, I think I've learned the most in this span of a month than I have in, I don't even know. Like, it's just an explosion of knowledge. And so, but also just working with my team was so special. And obviously at first it was kind of hard because we had to get to know each other. And also it was easy to come up with ideas for our mod, but it was hard to actually take the next step in code, because you can say that you're coding, but then it's like you actually have to go in there and write stuff. So yeah, it was just a really great experience. And the class itself was so structured. I was actually surprised because, like, when things go virtual, it's usually a bit shaky, but it felt like an actual class in person at times, and it was just very structured, and I really appreciated that.
It was really valuable learning about all about how to code in a group and how to merge our code using it in GitHub. I guess a challenge that our team had to overcome was to implement the UI, because none of us were really familiar with Keypainter and how to connect it with our code. Most of the time, our code just worked without us knowing why or how it worked. But with a lot of collaboration and a lot of help from the teachers, we were able to get a working game working at the end. And it was a really fun experience.
Yeah, so I think a lot of what I'm about to say has been said by a lot of people here because, C3. But I really enjoyed learning everything that we did in this course, both like the Python, about serious gaming, as well as like the concepts for like programming. Those are super cool. Also, I loved getting to meet a lot of new people here and not just my team. Like getting to know all you guys in Piazza and the Discord was really fun and I enjoyed it. And then also with my team, I really liked working on the code, making the UI, as well as trying new things with machine learning. And yeah, it was really great.
And I guess to round off C3, probably the aspect I enjoyed the most was kind of the insight into a professional career. So say in, 5 years, 6 years, we could be in roles utilizing these tools and, possibly even, not necessarily in the same roles as our instructors, but still along the same lines, in the industry, in the career fields that we go on to choose. And I feel like a lot of this class prepared us for that kind of, not subconsciously, but, subvertedly, I guess. So, that teamwork and the Git and the collaboration, that all, that's in a professional environment. So I guess I I just really enjoyed that aspect of it.
Thank you very much. And now we want to hear from Team A3.
Okay, so first of all, I just want to say that I really enjoyed this program and I had a great time working with my team and getting to know them better and hanging out with them on Discord. And I've worked a bit on teams before, but this really helped improve my skills and especially teamwork skills related to coding. Like I've never been a part of a coding project with more than just me. And it was I think it was really satisfying when I began to understand the code more, understand Python more in general as I worked with my team on the project. And one thing that I think that went really well with our team is our initial planning, because we ended up with a pretty fleshed out mod, complete mod, and I think we had just the right amount of work throughout the process.
Yeah, I want to echo what everyone else has said. I really enjoyed being in this program. I'd never, used GitHub before. I'd never done collaborative programming or any of that. So this was a really new experience, and I really, really enjoyed it. I loved working with my team. We had a lot of fun meetings and stuff like that, and so that was really fun. And to go off what Julian sort of said, I completely agree. I think we planned really well. We basically finished everything we wanted to do from the start, like right before the code freeze. So that was awesome. I do think one thing that maybe we could have thought about a bit more if we did this again was to worry about testing and everything, because we had a plan to train the RL agent using whatever features we implemented and see what strategies the agent would do. And depending on what the agent would do, we would adjust our stuff to sort of make strategies that we wanted to be better, to buff them and everything. But we didn't actually have enough time towards the end to adjust or anything or train the agent properly. And so I think that's somewhere where we could have improved a bit more on if we did it again. But like what Julian said, I think we really planned it really well, and it was a really good time.
Yeah, like everybody else has been saying, this course it's been phenomenal because it taught me so much, not even just about programming and programming practices, but also things that are going to translate that I'm going to need no matter where I'm going to go, right? No matter what kind of industry or academia we get into, things like requirements engineering and realizing all the stakeholders in a project and everybody that needs accommodated, and even other things like the Agile Manifesto, which was written for software development, but those same principles can be used in almost any other kind of project, right? So piggybacking off of what my last two team members said, I think one of my biggest concerns coming in was connecting with my team remotely, because you're not going to be in person and you're not going to be able to see them all the time and talk to them and kind of pal around and do the different things you would. But I know from our first meeting, our team just we clicked. Like, we were able to define our strengths, define our weaknesses, figure out what kind of gaps we needed to fill in and who could help where, and different things like that. And it was really great because our communication was open. So whenever somebody had a problem, all we had to do was put it in our Discord channel and say, hey, this is what I'm running into. Can anybody help me with this? And within a couple minutes, someone else was on them and explaining this is what they would do and helping them figure out and overcome their problems. So I think that was really great. And yeah, it's been a great course.
Yeah, it was the Beaver Works throughout all of SGAI. I really feel like I've learned so much about the code. Sure, the lectures were amazing and the seminars were great. I feel like the stuff that we went into, part of it was exactly what I expected, exactly what I wanted to get out of the course, learning so much more about AI and about game design. But then there were also so many fields that I didn't think I'd be interested in at all that I really clicked with, like project management. It's a little thing. It wasn't what I was expecting to learn coming into the course, but it really, I enjoyed setting up the deadlines and their requirements, and GitHub too. I feel a lot better about GitHub now from the beginning of the course. But not only have I learned a ton of technical stuff, I also, when I came into the course, I didn't really think that I was a big team worker. That was never the kind of work that I'd excelled at before. But our team, you guys really, really killed it. I felt like not only did we work together really well, and like David and Alex and Julian have said, we made friends with each other. I feel like we supported each other so much. I know that I didn't know too much GitHub, and everyone else on the team was really great about helping me out when I was struggling, or when we had a bug that needed fixing. We wouldn't just detail it, we'd live stream, and everyone would kind of hop in and talk about about how we could fix it, about what the issue was. We all put so much work into it. We were scrumming every night for like maybe, or not scrumming, we were meeting for like an hour and a half every night, which is crazy. And honestly, I'm just really proud with what we came up with. I feel like we've got a great we've got a great project. We hit everything that we wanted to do. And I just wanted to finish this up by saying thanks to all my team members for making it great, and thanks to the instructors. This was awesome, and everyone in this course. It was great.
I just want to say that first of all, it was an honor and a lot of fun to work with everyone, like especially my team, by working on the mod. It was nice to see like the turtle board empty out as we progress along, and seeing everything gets moved to completed and everything was empty. And it was a lot of fun coding together on Discord, even though sometimes it was silent. It's just nice to know that someone was there to help you if you ever needed help. And the debugging sessions was amazing. It was a lot of fun working out all the nicks and crannies about what's wrong with the code and fixing them. And also, we have made a lot of inside jokes, and I had a lot of fun making the Easter eggs in our mod and working together. And by deciding, like at first we brainstormed the mod ideas and filling up like 20 pages of the Google Doc about all the ideas we had and all the information about us, and just basically making friends together and working together during the course. And I also enjoyed all of the last lectures and the information I learned from the instructors, and all the technical skills I gained from this course. And it was just a lot of fun working together with everyone.
Okay, Michael, I think we have time for just a few questions, maybe like 4.
We'll do 4. We'll get right into it so we can get some in. First, I'm gonna ask this one to Beck Ashmore. Does your game modifications encourage you to change anything in your community? And if you could provide a quick example.
So yes, I definitely say yes, because it could be able to spur people to start considering other circumstances that are at play, like in the face of like a pandemic, such as taking into account that more impoverished like people or communities could be more susceptible to like said pandemic or viruses in general, thus hopefully instigating a chance of someone maybe wanting to take action to help those when those circumstances come around, and in general into those communities. Although just making people mindful in general of those communities and those circumstances are overall like a great effect in and of itself.
Great, thank you. How about Junha? What motivated you to choose serious games?
Well, I was looking through. I got accepted to the initial course of Beaver Works, and I was looking through the courses that I wanted to take, and serious gaming and AI in particular came up, I think, a little later than the other courses, and that it just really popped out to me. Well, okay, they have a module called zombies, so they're talking about something called zombies, and they are talking about changing games and how to design games to do experiments. And me personally, I really liked sifting, just like investigating within each game and like trying to figure out like things in the games. Like I've done task things for Minecraft, or not Minecraft, Mario Kart before, and like that connection just really clicked, and I really wanted to join this course.
Thank you. I'll ask Henry, how well do you think your modifications model real life behavior?
I think that for ours, we do a good job of capturing an aspect of society. But I think that if you were to combine like all of the mods together and make like one huge mod, I think that would do a pretty good job of modeling how society would react in a similar situation, because then it would encompass things like sanitation, different communities, trust. So I think that each mod does a good job at modeling a certain aspect.
Great, thank you. And our last question, Matthew, what was the hardest obstacle that you had to overcome in this course?
Probably like just working through the code and just trying to communicate with my team to be able to get everything done in time, probably. Because we had a lot of decisions to make with the team, and I always wanted to consult with my team first before doing anything myself. So that was pretty like a big obstacle, trying to get everything coordinated and working with my team.
All right, everybody, that closes us out. It has been a pleasure working with you. We will see you one more time this afternoon, and congratulations.